Welcome class, I'm Dr. April Ström, and in this video I'd like to showcase another example of the product rule where we are trying to find the derivative. So I have written the product rule in terms of our functions f and g so that you can kind of see what's happening here. So imagine that we have two functions that are being multiplied, so f of x multiplied by g of x, and we wish to find the derivative of that product. Well, to do so, we have to follow the rule, which basically says we're going to take the derivative of the first function, call it f, multiply by the g function, g of x. Then we will add to that the product of f of x, just as is, times the g prime of x. So what I advocate for this is that we make sure that we first start by setting up the line, the equation that has our derivatives there. The next line after that will actually take the derivative and then we'll be done. So here is my setup to all of this. We are going to say, for this particular function, call it h of x, where it's equal to x cubed times 3 to the x, we are going to set this derivative up by saying, all right, we're going to take the derivative of our h of x function. So I'll indicate that with the prime. So h prime of x will be equal to, now once again, I'm just setting this up. I'm not actually finding the derivative pieces, but you'll see notationally what I mean by this setup. So per the product rule, we need to indicate that we're going to take the derivative of our first function. Well, that's our x cubed. So I have my x cubed and I'm going to take the derivative of it in just a moment, but not yet. And now per the product rule, I need to multiply that by my second function, say in this case, 3 to the x. So I will multiply by 3 to the x. And you notice I'm introducing some parentheses here just to like separate the two functions from each other so you can see very clearly what the functions are and which ones we're actually taking the derivative of. But I'm not done because the product rule says now you have to add to that the first function again, which here is x cubed. And then we are going to multiply that x cubed, though, by the derivative of the second function, which is our 3 to the x, and then we'll indicate that we're going to take its derivative. So I call this the setup. It just sort of helps diminish, if you will, the cognitive load on the brain. If we can put the derivative in a form where things are set up, and now we can very clearly see, I just need to take the derivative of this piece here, and then this piece over here, and then I'll be done. So here we go. We've got h prime of x is going to be equal to, okay, now I gotta remember, I have to take the derivative of this function, x cubed. Well, it happens to be a power function. So thus we need to bring in the power rule, which says, bring this power down in front, then reduce the power that you had by 1. So now we have a new term, 3x squared. Once I reduce the 3 by 1, I have a power of 2. So that derivative is done. This is, 3x squared is the derivative of x cubed. And then I continue on. I just need to copy down the 3 to the x because all I'm supposed to do is multiply those together. And then I will add to it over here. I don't need to take the derivative of the x cubed. I already did that. So I'm just going to copy it down. And now we will multiply that particular function by the derivative of 3 to the x. Now be careful, because so often students will look at this particular function and think, well, it has a power, therefore maybe I could use the power rule. Not the case. In this particular function, this is an exponential function because the thing that's changing, the variable, is in the exponent. Notice over here for this function that we call a power function, in this case, the thing that was changing is in the base, not the power. So these are two very different functions. So as a result, my derivative process needs to be very different. So I must recognize that that 3 to the x is indeed an exponential function and then invoke the exponential rule for finding the derivative. So hopefully you remember what that is. It basically says we will bring the same function back again, 3 to the x, and we will multiply that by one constant. Special constant happens to be the natural log of our base, which is 3. So we have natural log of our 3 right here. And so now notice my line, my equation that I have here, no longer has any derivatives to deal with. I have taken all the derivatives, but here is my actual result of finding the derivative of this original function, h of x. Okay. I will also just quickly mention that if you want, maybe you could do a little simplification, but you don't need to. When you're finding the derivative, just find the derivative, and then you're welcome to stop so long as you don't have any more derivatives to take. Okay? So I hope you have enjoyed this video. Be sure to like the video and subscribe to our channel. And if you want more examples of the product rule, be sure to watch my next video.